Hello everyone, let's solve the Leetcode problem max area of island. You're given M cross N binary matrix grid. An island is a group of ones. Basically, the ones that you see in the diagram, these are representative of island and zeros are ocean. And something is only this basically represents a grid of zeros and ones. And if you have ones which are adjacent to each other horizontally or vertically, that is the definition of a connected graph as per the definition defined here, right? If it is part of the island, you want to be able to find the maximum area, and the way to find the maximum area is the number of ones in the adjacent cells. So for example, this would be 1. So if you have, just by the look of it, if you compute max area, this would be 1, this would be 4, 4 again, 5, and this is 5 again, this is 6. So eventually you look at all the max area and the eventual answer has to be 6. And if that is true, then you're getting the right answer. It's similar to number of islands, but here you're counting the area of the islands as opposed to counting the number of islands. So let's look at this problem. So the way you the logic here is basically you traverse through a grid, and every time you encounter an island, you immediately first record that as part of the island. You say the maximum. You increase the number of area to be 1, and then immediately turn that into 0, right? And the same. So the first thing you need to do is encounter one island. It's usually the left top corner, and then do the DFS on that. It's basically this way and then this way, right? And then eventually, as soon as you do DFS on it, first you find the island, then you do DFS on it, on the nearby neighbors, and then immediately turn that into zeros. Okay. And then again, once you encounter it, you take the top left corner, you do the DFS on the neighbors. Okay. The reason it's DFS as opposed to eventually in this particular case, there was three islands here. One was the max area was 1, another one was 4, and the final one was 5, which is this one. And that's why the max area is basically 5. Now, the reason it's DFS as opposed to BFS is the fact that you get the top left corner, you turn that into 0. Let's say you turn that into 0, and then you go to the nearby neighbor based on DFS, based on BFS, sorry. So, and then you get to this cell, and then you do BFS like this. You go to this cell, then you go to this cell, and then eventually you go to this cell. So it's basically the direction is this way and this way. But if you do DFS, then it's basically you take the top left corner and you do DFS on top. So it will go through these cells first, and then it will go through these cells in terms of counting. That's the difference between, let's say, BFS and DFS. So we choose the DFS here. So the time complexity of this problem is similar to, let's say, the number of islands problem, where the time complexity is basically O of M cross N. So M is the number of rows, and N is the number of columns. The reason is you traverse through it once, and every time, that's why you're converting everything into 0, so that you don't have to traverse the same cell ever again. If that is not the case, if you're not converting them into 0, there might be an infinite loop between two cells, and you go back and forth repeatedly. And the way to end that, in some of the problems, we store them as part of the hash set, and you say, these are the visited nodes. That's one approach. Another approach is convert them into 0, so that you don't have to go worry about counting them again. The space complexity of this problem is O of M cross N. Because you're using recursive DFS, So the amount of space that is required is the amount of, so it's already loaded as part of the memory. You don't need further memory because you're not going back and doing the search again. Okay. So let's write the code and see if this works. So we're going to code up max area of island. So the first thing we'll do is from, yeah, this is the library we need. We need some input that we have taken into, we'll put it here and we'll write the definition. So first thing we'll do is we'll get the dimensions of this. We'll get the dimension of the grid. Then we will initiate the depth first search method. Let's suppose we have depth first. What do we do with it? Our objective is to find the max area. And what do we search? We basically search whether the grid element is equal to 1. If it is equal to 1, then you update the max area. And how do you do it? Every time you encounter a island, you take the max of all the previous encounters of the island. And if this is true, okay. Before this, we have to define DFS, which is basically looking at all the corner cases. Or I can, or this should be N and this should be or. You don't want the grid to be not equal to 1 either, right? So if that is the case, you return 0, or else you update. This is, you update each grid entry wherein you have encountered an island to 0. This ensures you don't get stuck in an infinite loop. And then you call all the DFS functions, the boundary DFS functions, and then you add them up. I, comma, j plus 1. This should basically work. Yeah, the constructor which initiates the Let's see if this works. Oh, we have to save it. And if we run it, as you can see, the program, like, there was some error. Like, if max area is not indented properly, then the whole program goes for a toss. So it has to be indented properly. Now, if this is indented, you won't have this error, right? Let's run this. You're getting the answer as 4 now, because if you look at it this way, there are 4. I mean, 4 is the number of ones here is 4. There are 4 ones. That's why the area is 4. The second highest is probably 2. Now, if we change it slightly and make this, let's say 5. So this is not 5, right? This is 7 now. The area is 7. So let's see if we can get this. See, you get the answer as 7. And then you remove this again. Now it should be 5. You're getting 5. So this code works. If you have any questions, let me know. Thank you.